Hello, everybody. Welcome to the show. Mr. Viteri back at it again. Unit 9, Day 3. Still talking about climate change, and let's get to it. Okay. So, what does climate change necessarily do? As the temperatures keep rising, we have the melting of the permafrost. If you remember the permafrost, typically in the tundra, that means part of the soil is permanently frozen even during their summertime. Um, you know, there could be grass growing on top, and the first couple of maybe inches to feet are thawed out, and there can be life, but underneath that, it's permanently frozen. Now, here is a big thing to understand. Since this is frozen, all right, gases typically can't escape through ice. Now, as the permafrost melts, then you're going to release certain gases that may have been trapped in the soil. And we have found that methane is being released during the melting of the permafrost. So as the tundra begins to thaw, we're going to increase the release of methane. Methane being a greenhouse gas with a global warming potential that is more than CO2, could further cause the positive feedback cycle of global climate change or global warming. Hopefully you understand that. I used all the stuff that we've been talking about. So global warming potential, greenhouse gases, permafrost, melting, increasing of the temperatures. So if you could put all that together, okay, that is a positive feedback loop. And so the more methane that gets released, the more greenhouse gas there is, the higher the temperatures, the more the permafrost melts, the more the methane gets released, the more the temperature is going to increase. Okay, so as the permafrost starts to melt, or the glaciers start to melt, this is going to also cause sea levels to rise. As sea levels start to rise, coastal communities, Madagascar, people that live next to the water, all right, their populations may suffer because now you have a smaller amount of land available to them. What if their homes are there? They may be displaced. They have to move. Or, if you are an organism or a sessile species, you may not be able to move, and therefore you probably die. Okay. And so understand the connection between sea ice melting, thawing of the permafrost, and releasing that methane gas, also known as CH4, or methane, or natural gas. Let's continue. Now, climate change could also affect ecosystems. If we read this right here, oh, that's a sad picture. I don't even want to look at it. I don't cover it, but you know what? We got to look at it. All right. So some are positive changes and some are negative changes. So sometimes, melting of the ice would be beneficial to certain species, but negative species could also become affected. Okay. The lack of ice it causes a problem for polar bears. This was a free response question, I think 2 years ago. And the polar bears, since there was less sea ice, they wouldn't be able to hunt properly. Okay, and because the polar bear typically will, if there's a lot of ice, the polar bear waits at a little hole where a seal might pop up or a whale might pop up, and it's going to wait there, and then as soon as a seal, because there's so much ice, comes up to breathe, they're going to grab it and they'll eat it. Or they'll keep on scratching a whale as the whale tries to breathe. And then that's how they get their food. Now, if there is no holes because there is no ice, then that throws a wrench in how the polar bear typically hunts. And so it's going to have to swim a lot farther to try to find food, wasting a lot more energy. And so polar bears could end up starving. And that was one of the case studies. You had to explain that whole thing. So hopefully you understand that now. Okay. Okay. And so notice that sometimes organisms need that ice for food and habitat, particularly the polar bears in this case. Let's keep on going. Okay. Climate change could also affect the wind circulations by impacting the temperatures of the ocean. Okay, so vice versa, if the ocean warms up, that ocean can now warm up the air. If the air is warming up, that air is warming the ocean. And we talked about a circulation pattern called El Nino. And El Nino, right, is the bad one. And La Nina is the good one. That's the normal conditions. And during El Nino, that cold water does not come up. So instead, you have warm air and warm water, which causes a lot of precipitation. So you have immense flooding over here. Okay. And South America isn't built like that. It's not built for that. Right. If the cold water comes up, then it moves this warm air over to Australia, over to Asia. And, there's a lot of rice paddies that are need, and the farming economy is kind of set up that way, where they need the tremendous amount of rain that actually that brings. And so we could say that because of climate change and its impact on the Hadley cells, or their impact on the ocean currents, then you're going to have more intense storms in South America and the United States, because it's going to be coming up here as well. All right. So warm air carries more precipitation than cold air. Try to remind you, El Nino, La Nina. El Nino's bad. We talked about during La Nina, we have good fishing. During El Nino, we don't, since there's so much more precipitation during El Nino. I told you about my trip to Peru. It was a planned trip to go to Peru, but they had so many mudslides because there was just so much precipitation going down there around that time when we were planning as a family to go down. Let's continue. So, once again, ocean currents are affected by global warming. They could change, they could weaken, and these could have a big impact on coastal communities and coastal regions around the world. All right. Um, this will change fishing industries. This will change, you know, ecotourism and beach dwellings. All right. So, let's read this here. Oceanic currents or the ocean conveyor belt carry heat throughout the world. When these currents change, it can have a big impact on global climate, especially in coastal regions like El Nino, like La Nina. This could be, and we're supposed to have a very intense hurricane season 2021. And it could be in part of global warming. I will say is in part of global warming, of making either these ocean conveyor belts stronger or weaker or changing from predictable patterns that are typically here. All right. And here is an interesting one. How can global warming really affect our soils? Okay. So, because of global warming, and there's going to be immense rain in certain regions, our soil could get washed away.
Good morning, John F. Kennedy Memorial High School.
So areas will get a lot of precipitation, but there's going to be a lot of areas, since the precipitation has moved, to get dried out. When those areas get dried out, now they're more susceptible to wind blowing them away and erosion. So I wrote here, and this is a shout out to Jason. Jason, I think soil is much more valuable than Bitcoin. And that's funny because I think it went down to $32 a share. I mean, it's not funny if you lost money. I apologize. But anyhow, we have this debate going on over here. All right, so it could even affect soil. That is so crazy. Think about it. Think of the connections. I could see free responses perhaps trying to inkle and point you in these directions. Okay, so how could you fix this? Perhaps slow down the release of greenhouse gases, eliminate fracking, change transportation, industry, use renewables that don't emit CO2. Okay, these are all things that should be in your head, and we're going to destroy this AP exam. All right. Let's leave it off of this last slide here. And this is the beautiful albedo term. Okay, albedo. If you are light in color, you have a lot of albedo, meaning that you reflect the sun's infrared radiation. It's basically going to go back into outer space. But if you are dark in color, if you have a black t-shirt on, it's going to absorb a lot of heat. Okay, so that is that term albedo. Know that term. Okay, and we're going to go back to a positive feedback loop and understand what a positive feedback loop means. Now, look, snow and ice is white in color. Look, when the sunlight comes down, 90% of that is bounced back into the atmosphere. So if you have snow and ice, that means 90% is going back into the atmosphere. Only 10% is being absorbed. Now, if you are the ocean without snow and ice, look, 94% of that energy is being absorbed, and only 6% is being reflected out into outer space. In this case, what means is that the oceans are going to get warmer and warmer, and they're going to cause the snow ice to actually melt even further. That is how we get a positive feedback cycle. Please be able to explain that with words. Okay, so as the polar ice caps start to melt, they get less albedo, and the oceans absorb more sunlight, and getting warmer, decreasing the snow and ice. Okay, and the oceans absorb a lot more heat than the ice caps, therefore increasing global warming in a nutshell. All right. All right, let's keep going. And I think that's going to be all for today. You are amazing. I think we only got 2 more days of lecture, and then we should be complete. Let's just finish this last one. This is ocean warming. We've spoken about it multiple times. As global temperatures rise, so do the temperatures of the ocean. All right, they are rising because of the increases in greenhouse gases, particularly carbon dioxide. Okay, so as the greenhouse gases start to increase, then the temperature of the atmosphere increases, then the temperature of the ocean increases. As the temperature of the ocean increases, the algae that live on the corals die. It's a mutualistic relationship. They die. The corals become white. This is called coral bleaching. Okay? And so coral bleaching is a result of global warming. All right? This decreases primary productivity or gross primary productivity and decreases the biodiversity of that region. Oh, I love putting all these words together. Hopefully you're following me. You're an amazing class. I'll talk to you later.